Quarter circles, like those replicated here, have been found at various pyramid sites. It seems quite evident that they do have a definite purpose. The block is 4,200 pounds, and the person pushing the block is 5 feet 5 inches tall and weighs 135 pounds. While one person can roll a block, 3 people are specified in the paper.
The problem with the standard methods is that the quarry is simply too small. This is the size of the quarry. This is the amount of material that is used for the Great Pyramid. And as you can see, it fits very nicely. But that's not the whole story. As we discussed previously, there's a huge amount of waste that's used using the standard methods of quarrying. This is the amount of wastage that has to be added in. Now, on top of that, we have ramps. And if you're going to use the smallest ramp that is feasible, and that's questioning it, you need at least this much more, 30%. So as you can see, the quarry problem is that you need over 2.5 times more material out of the quarry than what the quarry is capable of holding. Now let's examine what happens if we use a spear chisel and use levers to raise the blocks instead of a large ramp. See how that affects the quarry problem. We start out with the amount of material from the pyramid. That looks pretty good. And then we add in the amount of wastage that you get when you use a spear chisel. Now that is pretty close to fitting, but it's not really quite, just a little bit high. And it turns out there's a second order correction that I haven't mentioned yet, and that is that there's a hump of bedrock underneath the Great Pyramid. And that means that the actual amount of material taken from the quarry versus the volume of the pyramid is actually a little bit less, because you don't need to fill in the hump. And this is the amount of material that we have to remove in order to get rid of the hump. And once we do that, we find there is no quarry problem whatsoever.